English medium channel. Correct? So today we will discuss the geometrical and optical isomers of octahedral. In that first we'll see the geometrical and how many opticals are there. So in this total stereoisomer, if we see total stereoisomers, how we are going to calculate how many geometrical isomer are there and plus how many optical isomer are there. Correct? So based on that, we will decide it. Let's see with the example. So suppose we have this example, cobalt, hexaamine, okay, and Cl3. So just look this molecule. This is an octahedral molecule, correct? So just we will convert it to the general formula. Like organic chemistry we have for alkane CnH2n plus 2, alkene we have CnH2n, like that for the coordination complex also. To find out the stereoisomers, whether it's geometrical isomer or optical isomer, we need to convert it to the this formula, right? So this we convert it to Ma6, where M is central metal, correct? And what is the A? A is ligand, and this 6 is coordination number of this metal, correct? So based on this, we will just draw how many possible isomers are there, and then we'll see that optical activity of those compound, correct? And where A is ligand, this is monodentate ligand, okay? Monodentate ligand, okay? I'll just discuss you later what is monodentate, what is bidentate, what is polydentate. Like EDTA is hexadentate, right? EDTA is hexadentate. So that I will discuss, है ना? So now just we will see for Ma6. So this is metal, and for octahedral, just based on VBT, we know that this will be the structure, geometrical arrangement, right? This will be in planar, square planar, and one is axial. Both are in axial. Remaining two are in axial. So these are like this. Now you just see here. This is Ma6 type of molecule, and how it is octahedral? See, this way we can form it octahedral. Above fourhedral, how? So this is left side, okay. This one is right side hedral. This one is back side hedral. You have to imagine, you have to lot of imagination you have to put in your mind, then only you can solve it, right? This is front side hedral. So how many hedrals are there? Upper side, 1, 2, 3, 4, correct? Now below we have to see. This is front side hedral. This one is right side hedral. This one is front side. And see, this one is left side hedral. And one is there, which will be back side hedral. How we will going to form it? This one. This one. This is back side hedral. So below also four hedral. So four hedral and four hedral. Four hedral, four faces, right? So four hedral plus four hedral, eight hedral. And then its name is octahedral, correct? So like we have to name it. Now whether any possibilities there, whether we can arrange it with any other form, like any other form. Suppose this A is there, all are A, right? All the ligand is similar ligand. So we can't modify it. Suppose if you want to say that this A we are going to put it here, then we will get the similar one, right? So in this, we can say how many geometrical isomer is there. We can't form it cis or trans, right? You can't say whether it is cis or trans. So geometrical isomers is 0. And then optical activity. How we are checking optical activity? Again, I'll form this same molecule. The one good thing is practice more. Okay, the more times of if you are drawing, you will be better understanding of any molecule, correct? Suppose this is the octahedral molecule. I'm passing a mirror from this A, this middle central atom and this ligand. See what is happening? This A and this A is reflecting, this A and this A is reflecting for this mirror, correct? So both are mirror image, and if we are getting mirror image, we can say this one is having plane of symmetry. If any symmetry elements, you know, right, symmetry elements are there, plane of symmetry, center of symmetry, axis of symmetry, then these are the symmetry. If any one is present, then we can say that this is optically inactive. Okay, here one horizontal plane also we can put it, this place. So this one plane, if we are putting, this A is reflecting to this A, correct? So here also plane of symmetry is there. If we put mirror like this A will reflect to here. So here also plane of symmetry. If we'll put the mirror like this A will reflect to this. So here also plane of symmetry is there. If we'll put the mirror like this A will reflect here, this A will reflect here. Correct? Here also plane of symmetry. If we'll put mirror like this A, they will reflect it. Correct? So uh, like that, you have to find it. If any mirror of symmetry, like plane of symmetry is present or center of symmetry is present, then the molecule, the complex molecule will be optically inactive. And don't try to draw with this molecule. You just convert it to the this form. So it can be drawing a better way, right? If you are putting NH3, and then if you miss somewhere, then you will say that there is geometrical isomer, correct? So don't draw like this. Just convert it to this general formula Ma6. If anything, say this one is M, this one is A, monodentate ligand, and how many ligands are there? 6. So we are putting Ma6, correct? So likewise, we'll see the another molecule. For this molecule, geometrical isomer 0, optical isomer equal to 0. How many isomer are there? Stereoisomer, stereo, stereoisomer 1. So now how this came for stereoisomer 1? We have identity, right? E. So this one is we call, if there is no isomer is present, whether it's geometrical isomer or optical isomer, we can say it self isomer will always be present. Okay. Self isomer. So in this place, we can say one stereoisomer is present, but geometrical isomer 0, optical isomer 0, but stereoisomer 1. Correct? So don't confuse with the stereoisomers. If in question asking how many stereoisomers are there, so 1. If they are asking how many geometrical isomer is there, 0. If they are asking how many optical isomer are there, 0. They can ask also how many plane of symmetry is present in this molecule. So you have to count it. 1, 2, 3, 4, 5, 6. Total 6 plane of symmetry you can find it, right? So likewise, they can ask 6 plane of symmetry also. They can ask, see, this is 1, okay. Then, okay, 1, we'll count it. It is not 6. 1, then 2, then 3, 4, 5. 5 will be there, okay, not 6, 5. So 5 plane of symmetry. So likewise, you have to calculate it, correct? In that, this will be your sigma plane, horizontal. So sigma h, remaining will be your sigma v. So 4 sigma v and 1 sigma h. Sigma h is plane of symmetry present in horizontal way. Sigma v is plane of symmetry present on the vertical way. That we are founding with based on the principal axis. I'll show you just now because otherwise you will get confused, right? So let it draw it again. This is A. What is principal axis of symmetry? See, one axis you just passed it. This is one axis. This is not mirror. This is axis. Just rotate it. So the rotation you give, first rotation I have given 90 degree. Let's see what is happening. This is A1, A2, A3, A4. What is happening? Let's see. Okay. Now the rotation is like this. So A2 will go here. A1 will come here. A4 will go here. A3 will go here. Then again you just give rotation 90 degree. Okay, now A2 will come here. we are finding the principal axis of symmetry, right? Principal axis, let's see, not symmetry, principal axis. We are finding principal axis. So now what is happening? A2 will go here, A1 will come here, A4 will go there, and A3 will come here, correct? Then again 90-degree rotation will give. Why we are giving this rotation 90-degree? We want to like this A1 should come here again, okay, this position. So how many rotations are there? That will be your C3, C4, C5, whatever is coming, we will put it, okay? So for one example, we'll do like this. Remaining, you have to imagine it, okay? Because imagination also only you can do it. Otherwise, this one is time taken, right? So imagination part, it should be strong. So A1 will go there, A2 will come here, A3 will come down, A4 will go there, right? Now again 90-degree rotation. Now what is happening? So this rotation, let's see, A1 will come here. Okay, so now you just see A1 is coming here in the same similar position, A2 is coming here, then A3 is coming here, A4 is coming here. Just see, these two are similar. Here A1, here also A1, here is A2, here also A2, A3, A3, A4, A4. Everything is similar. So how many, excuse me, how many rotation we have given? 1, 2, 3, 4. So total 4 rotation we have given. So we can say that this molecule is having C4 principal axis. C4 means 4 times we have to rotate it, then only the same molecule can come in the similar place, right? So C4. So this is your C4, and if this way if you are taking the rotation, how many rotation we have to give to come to the similar place? Suppose first rotation you are giving 180-degree, A3 will go there, A2 will come here, right? Second rotation again you give, A2 will come here and A3 will go there. So this will be C2 axis of rotation, right? If this way you are taking, how many rotation? First rotation 180-degree, these are 180-degree, right? 180-degree. So first rotation if you are giving, A3 will go there, A1 will come here, correct? Second rotation if you are giving, again this A1 will go there and A3 will come here. So here also C2 axis of rotation, correct? And one more axis of rotation here, this one, C2. Here also C2. First A4 will go there, C3 will come here. Second A3 will go there and C4 will come here. So these are the subsidiary axis of rotation. This one is center axis of rotation or main axis of rotation you can say, or principal axis of rotation you can say it, C4. And subsidiary, how many are there? 1, 2, 3. So 3 subsidiary axis of rotation are there. These are C2, right? So this is now this one is the principal axis of rotation, C4. So perpendicular to C4, which mirror plane are there? This horizontal one, right? Perpendicular to this C4, this mirror plane is there. Which one? In this A, and this A is reflecting. So that we call sigma H. Okay, perpendicular to the principal axis of symmetry, we call it sigma H. And uh, parallel to this C4 axis, we call sigma V. Okay, like this you are cutting, correct? This place you are cutting, both are sigma V. So 4 sigma V, 1 sigma H, right? Total 5 plane of symmetry are there, correct? So subsidiary axis of symmetry, subsidiaries rotation, and the principal axis of rotation, you understood, right? Uh, so now we'll go for the second type of molecule. So this molecule, if they are asked, suppose this molecule, how many geometrical isomer are there? 0. How many optical isomer are there? 0, because we are converting here to the formula, right? Now next molecule we'll see Ma5B type, correct? So example, just take it. Many example are there, right? Just you have to convert it. So like this example, see, central metal. Oh, 1 second. Central metal, and these are monodentate ligand, right? So A, how many are there? 5. and this one is also monodentate ligand. This is different type of ligand, so we are putting B. Correct? So central metal ligand, one type of ligand. This is second type of ligand. This is second type of ligand, and yeah, this is A5, and this second type of ligand is 1. Okay, B. So total MA5B type of molecule we can prepare it, right? So now we will just draw it and see how many geometrical and how many optical isomers are there. So this is A, 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 B, A. Correct? This way we can form it. One more we can form it. Let's see. Just we'll put B here, then A, 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 right? Remaining, if you are drawing, it will be like similar kind of thing. Suppose if you are drawing like this will be suppose A, and you are putting B down. See, both are same, right? Both are identical. There is no change. These two are identical. Here we can say it, this B is in axial position now. Like this B is in axial position. Here this B is in equatorial position. Correct? So, but there is no differences because in octahedral molecule, like any side can be the axial and any side can be the equatorial if all the ligands are same. Correct? So now just you think it like any other name you can find it. We can't say it's cis or trans because this is the different thing. With this B, one more B should be there, like different type of ligand should be there. Then we can say this is cis, and if this B and another one more B is here, then we can say it's trans. So here also these are similar. So geometrical isomer 0 and optical isomer also 0. So stereoisomer, how many stereoisomer? 1, because self isomer will be there. Now for optical isomer, you will say that okay, if we are passing mirror here, it is not reflecting, right? B is not reflecting to A. A is reflecting A, but B is not reflecting to A, correct? So how come like this plane of symmetry is absent? So it should be optically active. Just see it. We'll put the mirror like this. Suppose we are putting mirror like this B and this A along with the A and B. Okay, if we are putting mirror like this A is reflecting to this A, correct? So what I said in the previous slide, that if any one symmetry of elements are there, then the molecule will be optically inactive, correct? So in this case, this A is reflecting to this A. So here this is optically inactive, right? Any molecule you can take it. You pass mirror from this side. This A is reflecting here. This A is reflecting here. So this also plane of symmetry is present. Here also plane of symmetry is present. Okay. Here also we'll see it. B is here. Just pass the mirror like this. This A is reflecting. So plane of symmetry is present. So all are optically inactive. Correct? All are optically inactive. So this molecule is having only one stereoisomer. Only one. Sorry. Only one stereoisomer is there. If they ask how many geometrical isomer are there, so 0. How many optical isomer are there? 0. Like that you have to answer it. Okay. Next, if you like these classes, uh, if you like these classes, kindly join. That only I can say it. Kindly join our app GChem classes. You will find it in Play Store. Okay, and which competition do you like? You just say it, and medium also. This is very important because from today onwards, I am starting for English medium. So it is nowadays like from going forward, you don't have you don't be having problem whether you are in from English medium or Hindi medium. Okay, you have to mention it in English medium or Hindi medium. Correct?